Space-time travel has been a topic in many science fiction works. For example, in H.G. Wells's intriguing novel, The Time Machine, the hero journeys to different times in the future. In the science fiction movie Stargate, characters quickly travel through a wormhole or a structure that is a shortcut between space and time to different galaxies. And in the American TV series Star Trek Deep Space Nine, wormholes are used to transport people from the Alpha Quadrant of our galaxy to a remote Gamma Quadrant. Is space-time travel really possible? Let's now look at what scientists say about this fascinating phenomenon. In conventional terms, space is defined as having three dimensions, namely up-down, left-right, and backward-forward. Time, which progresses independently, constantly, and linearly forward, is added as the fourth dimension. In this model, light travels straight forward unless blocked or reflected by other objects. However, when an event occurs, it must occur in a certain place and at a certain time. Thus, events occurring in the physical universe must involve both time and space. Time cannot exist without space, and vice versa. This interconnected relationship is known as the space-time continuum. This model of space and time held true until Albert Einstein's introduction of his special and general theories of relativity. According to Einstein, time is not constant but is instead relative and elastic. People are affected by time differently depending on their speed and the gravity field they're in. When an object moves at a high speed, time slows down relative to that object, a phenomenon known as time dilation. Scientists in Germany and the United States have confirmed that time passes more slowly on the ground than it does on the top of a high building, meaning that gravity also slows down time. Einstein stated that the highest speed an object can travel is the speed of light. And because the relativistic mass of an object increases as its speed approaches that of light, the relativistic mass of the object is infinite at the speed of light and so cannot be accelerated further. Based on Einstein's general relativity theory, both space and time are flexible. They can fold and curve, which can bring two locations far away in space-time close to each other. When an object with mass is present in space-time, it causes space and time to bend or curve. To understand this space-time curvature better, let's imagine that two people are holding a bed sheet and stretching it tight. If a baseball is placed on the sheet, it will roll to the middle and cause a curvature in the sheet at that place. If a marble is placed on the edge of that same sheet, it will move toward the baseball due to this curvature, which in space-time is considered to be gravity. Now let's imagine that the sheet is folded over with a space between the top and bottom layers. If a curvature occurs on the top layer and another on the bottom layer at the corresponding site of and toward the curvature of the top layer, the two layers of the sheet may meet each other and form a shortcut bridge connecting the layers. This is how scientists think a wormhole might be formed in real space-time. Masses that give pressure to different parts of the universe could come together to form tunnels. In 1921, after analyzing the theory of general relativity in combination with electromagnetic field energy, German mathematician Hermann Weyl proposed the theory of wormholes, in which he called the structures handles of multiply connected space. However, inspired by the phenomenon by which a worm takes a shortcut from the surface of one side of an apple to the other by tunneling through the interior, U.S. theoretical physicist John Archibald Wheeler was the first to use the term wormhole in 1957 to describe the hypothetical topological structure that is fundamentally a shortcut through space-time. A wormhole connects two locations in space-time, which in principle would allow objects such as particles or even spacecraft or UFOs to travel in time as well as space. Two types of wormholes have been proposed, the first of which is called the Schwarzschild wormhole, or Einstein-Rosen bridge. In 1916, shortly after Einstein's publication of his general theory of relativity, Austrian physicist Ludwig Flamm looked at one of the simplest possible solutions to Einstein's field equations, known as the Schwarzschild solution, which describes the gravitational field around a spherically symmetrical, non-rotating black hole, a region of space with such enormous gravity that nothing, not even light, can escape from it. Thus, a black hole creates a tremendous curvature in space-time. Flamm noticed that in addition to black holes, a second solution to Einstein's equation was allowed, involving another kind of gigantic object known as a white hole, which is the opposite of a black hole and may be viewed as a black hole running backwards in time. A white hole is a hypothetical region of space-time that cannot be entered from outside, but from which matter and light may escape. These two solutions to Einstein's equations describe two different regions of space-time, black holes and white holes, which are connected by the Schwarzschild wormhole. However, nothing can be transported through the Schwarzschild wormhole because it is highly unstable. Its tremendous gravity drives it to elongate along its length and pinch off in the middle. Even the tiniest amount of matter, such as a single photon, will cause it to collapse when attempting to pass through it. Additionally, the object will be sucked into the core of the black hole when it gets close enough, before it even has a chance to exit from the other end of the wormhole. Wormholes through which objects can move, known as traversable wormholes, require exotic matter that has negative energy density and negative pressure or tension to prevent the wormholes from collapsing. The exotic matter that is repelled by gravity instead of being attracted forms a thin, spherical shell by threading the throat of the wormhole to stabilize its shape. In 1988, Michael Morris, Kip Thorne, and Yuri Yurtsever of the California Institute of Technology, USA, stated that a journey across interstellar distances at translight speed might be possible if a wormhole could be held open long enough for an object such as a spacecraft to pass through it. This would require exotic matter with a negative energy density and a negative pressure larger than the energy density to keep the wormhole open. In the process of seeking such exotic matter, Morris, Thorne, and Yurtsever turned their attention to the quantum vacuum, or empty space in lay terms. It has been noted that empty space is not empty at all, but has fleeting electromagnetic waves and particles that continuously come into and out of existence. If two uncharged conducting plates are put in a quantum vacuum close to each other, only those electromagnetic waves whose wavelengths are a whole number of times of the gap should be counted when calculating the vacuum's energy. When the gap between the plates is reduced, fewer waves can contribute to the vacuum energy. As the gap is reduced to a few nanometers, the energy density between the plates is lower than the surrounding space, thus resulting in a tiny force pulling the plates together, a phenomenon known as the Casimir effect, first predicted by the Dutch physicist Hendrik Casimir in 1948. It is said that the ultra-small wormholes continuously appear and disappear in quantum vacuums. It is believed that these tiny wormholes could be expanded to macroscopic size by adding energy in a sufficiently scientifically advanced civilization. The wormhole could then be stabilized with the Casimir effect by placing two charged, superconducting spheres in the mouths of the wormhole. Transporting the mouths to distant regions of space would make it possible for faster-than-light communication and travel. For example, when using a spaceship to carry a wormhole mouth to a location many light years away, though the spaceship has to travel at sublight speeds, communication and transportation through the wormhole could be faster than light traveling to the same location via normal space. In addition to faster than light travel, traveling to the past and future is also possible by converting a wormhole into a time machine. This could be accomplished by accelerating one mouth of the wormhole to a high velocity. According to the principle of time dilation, the mouth with high velocity would age more slowly than the other mouth of the same wormhole. Thus, a person entering the accelerated mouth would exit the other mouth ending in a future time. Vice versa, a person entering the mouth without acceleration would exit the accelerated mouth at a time in the past. For example, if 3 clocks are set to the year of 2000, one is put in the accelerated mouth, one is put inside the other mouth of the wormhole, and the third is taken on a trip from the accelerated mouth to the other mouth. At the end of the trip, the result may be that the clock in the accelerated mouth reads 2005, the one in the other mouth reads 2010, and the clock that traveled from the accelerated mouth to the other mouth reads 2005, which is 5 years behind the clock that was put there in the beginning. However, this type of time machine would not allow for travel to a time point that has not been experienced by the mouths of the wormhole. Though time travel and faster-than-light travel are still only scientific theories, researchers are taking it seriously in the belief that it could turn into scientific fact in the future. Traversable wormholes that allow for transportation of objects between locations in space-time of the same universe or between parallel universes are fascinating and powerful concepts. In an October 3, 2010 video conference with the Supreme Master Television staff in Los Angeles, USA, Supreme Master Ching Hai discussed the topic of wormholes in response to a question about them.
Are there locations on this planet where wormholes exist, where we can travel in between different dimensions or places in the universe? Sometimes we hear that UFOs can visit our planet via these so-called wormholes.
Yes, these holes do exist. Yes, there's like portals connects between different dimensions. Yeah, if UFO go, it's quick through this way. Yeah, okay, like a universal highway, you know. Okay. For material means only, yeah. For a spiritual portal, we have to practice the light and sound, okay?
Will people from our planet experience space-time travel in the near future? If so, where would we go on our voyages? These are some questions to contemplate the next time you gaze at the stars above on a clear night. Enterprising viewers, thank you for your company today on Science and Spirituality. Coming up next is Words of Wisdom after noteworthy news. May the light of love and blessing in the universe shine upon us all.
For more details, please visit www.suprememastertv.com/SS